So we're going to talk about the fundamental theorem of algebra and the number of zeros theorem. So let's just jump right into it. So the fundamental theorem of algebra says that every polynomial that is degree 1 or more has at least one complex zero. And so when I say complex zero, I just want to be clear about what I mean with that. So the word complex zero, I think a lot of times people think of like something like 3 plus 2i. It's got to be an imaginary number. So this theorem isn't saying that you have to have something of this form. So things that also are technically complex zeros would be like 3 or pi. So really what that means is that anything complex or real is okay. So the fundamental theorem of algebra says that every polynomial that has degree 1 or more has at least one complex zero. Now, connected to that is the number of zeros theorem, because we'd like to know, okay, it has at least one. Can we quantify like maybe the most? And so the number of zeros theorem then says that every polynomial that is degree n has at most n distinct zeros, okay? So in some ways, I think the fundamental theorem of algebra, it's a little like you've been using it your whole algebraic life without even really thinking about it. So this is not really that deep in some ways, like because it's just something you've done without realizing it. But the number of zeros theorem, now this is something that's kind of powerful and interesting. So let's take a look at the following. So let's say that I just want to know what are the max number of possible zeros for each of these. So what you do then is you look for what is the degree of the polynomial, which in this case is 2. So there are at most 2 zeros. So what this says then is you are required to have at least 1 zero from the fundamental theorem of algebra, and at most 2 unique zeros. Okay, so what about b? What is the max number of possible zeros for this function? Well, in this case, the degree is 17, so we could have up to 17 possible zeros. Now, we have to have at least one. It could be repeated 17 times. You could have some of those zeros repeat, so you might have less than 17 unique ones, but you're going to need to have 17, at most 17. Now, finally, what about the function f of x equals 9? Well, in this case, this has no zeros. This is a degree 0 polynomial, so this one has no zeros. So the fundamental theorem of algebra says you have to have at least degree 1. This is degree 0, so no zeros in this case. And so that's kind of what these theorems are getting at. Now, a related question to this would be, I could ask you, so find a polynomial with the zeros -3, 3, and 1, where f of 2 equals -10. All right, so the structure of a polynomial that we want to work with here is we want to take into account these 3 zeros. So, all right, let's set this up. Now, let's leave a little space. Just watch me for a second. I'm going to leave a little space here. This becomes x plus 3, x minus 3, and x minus 1. So notice for each zero, for the factor, I've talked about this in other videos too, right? You always take the opposite sign. So you got to keep that straight. That can be a little confusing. Okay, so we know for sure that these are the 3 zeros, but here is the slight twist that we have to worry about. There could be a number in front of all of these factors, okay? So you want to remember that every polynomial has a structure of a, some number a, times all of its zeros. Now I want to give you another way to remember this. So notice that in setting up the zeros, I have only used this piece of information. And a lot of times with math problems, so it's true some math problems will give you information that you don't need. But in this case, this piece of information here, we do need this. We need to use this. And so the way that you use this now is I'm going to plug this 2 in for this. And I know what the result should be. If I plug this 2 in for the x's, this whole thing should equal -10, right? So let me do that. I'm going to take 2 plus 3, 2 minus 3, 2 minus 1. This is all going to equal -10. Okay, so let's sort this out. This becomes 5 times -1 times 1. So this equals -10. So what I get is that 5a equals -10. And if I divide both sides by 5, what do I get? I get that a equals -2. So as you can see, there was some other constant in front of this. Okay, so my final polynomial then, let's see, I'll maybe write it here. My answer is f of x equals -2, x plus 3, sorry, I'm running out of room, x minus 3 and x minus 1. Okay, so I have another one here. So why don't you try this one on your own and hit play when you think you've got it. Okay, so I'm going to set this up again. So my zeros were 6, 3, and 2. So notice that I take the opposite sign for all of these. And now I've used this piece of information. I still need to use this piece of information. So I need to plug the 1 in. So this becomes 1 minus 6, 1 plus 3, 1 plus 2, and all of this needs to equal 20. So let's see if a will equal anything. So if I simplify this all, this is -5, 4, 3, so that's going to equal still 20. So -5 times 4 times 3 is going to equal -60a. So if I divide both sides by -60, this will simplify to 1/3, -1/3. Okay, and so then, let's see, I'll clear a little space here. All right, so my final answer then is -1/3 x minus 6, x plus 3, and x plus 2. And so there you have it. Okay, so that was just a short and sweet video. If this was helpful, please consider leaving a like, a comment, or subscribing to the channel. And otherwise, I will talk to you guys in another video. Thanks for watching.